Task number 3, HTTPS. HTTP, Hypertext Transfer Protocol, is the protocol that specifies how a web browser and web server communicates. Your web browser requests content from the TryHackMe web server using the HTTP protocol as you go through this room. So in simple words, we always use HTTP protocol in order to request a web page on a server. As we study in the networking core protocols, Room HTTP relies on TCP and uses port 80 by default. We also saw how all HTTP traffic was sent in clear text for anyone to intercept and monitor. The screenshot below is from the previous room, and it gives a clear idea of how an adversary can easily read all the traffic exchange between the client and the server. We make the request, the GET request, and we get the response, the 200 OK from the server. And you can clearly see it. Everything is in clear text, right? Let's take a minute to review the most common steps. Before a web browser can request a page over HTTP after resolving the domain name to an IP address, the client will carry out the following two steps. Establish a TCP three-way handshake with the target server, and then communicate with using the HTTP protocol. For example, issue HTTP requests such as GET root HTTP version 1.1. The two steps described above are shown in the window below. The three packets for the TCP handshake marked 1 precede the first HTTP packet with GET in it. The HTTP communication is marked with 2. The last three different packets are the TCP connection termination and are marked with 3. So we have the first 3 is sequence 1, acknowledgement, okay. Sin, ac. And then the second window, acknowledgement. The third window, fin, ac. Perfect. Again, captured with Wireshark. Hypertext get HTTP 1.1 version. HTTP over TLS. HTTPS stands for Hypertext Transfer Protocol Secure. It is basically HTTP over TLS. Consequently, requesting a page over HTTPS will require the following 3 steps after resolving the domain name. Establish a TCP three-way handshake with the target server, establish a TLS section, and then communicate using the HTTP protocol. For example, issue a HTTP request such as get root HTTP 1.1 version. The screenshot below shows that a TCP session is established in the first 3 packets, marked with 1. Then, several packets are exchanged to negotiate the TLS protocol, marked with 2, 1, and 2, are where the TLS negotiation and establishment take place. Finally, HTTP application data is exchanged, marked with 3. Looking at the Wireshark screenshot, we see that it says application data because there is no way to know if it is indeed HTTP or some other protocol sent over port 443. And you can see here again the 3 sections, but this one is with TLS certificate. You can clearly see the protocol used in here, TCP, but here we see obviously the TCP, but we see TLS. Again, captured in Wireshark. As expected, if one tries to follow the stream of packet and combine all their contents, they will only get a gibberish as shown in the screenshot below. The exchange traffic is encrypted. The red is sent by the client, like always, and the blue is sent by the server. There is no way to know the contents without acquiring the encryption key. So in the above example where we only used the HTTP via TCP transport protocol, check this out, everything is clear text, but when we use HTTP over TLS, Boom, there you go. Without encryption key, you basically cannot encrypt anything. Getting the encryption key, adding TLS to HTTP list to all the packets being encrypted. We can no longer see the contents of the exchange packets unless we get access to the private key. Although it's improbable that we will have access to the keys used for encryption in the TLS session, we repeated the above screenshot after providing the decryption key to Wireshark. The TCP and TLS handshake don't change. The main difference starts with the HTTP protocol Mark III. For instance, we can see when the client issues a get, and then we request the login page. Get the login page. If we want to see the data exchange, now is your chance. It is still regular HTTP traffic hidden from priori eyes. In Wireshark, again, we can see the request for the login page, clear text, everything, right? The key takeaway is that TLS offered security for HTTP without requiring any changes in the lower or higher layer protocols. In other words, TCP and IP were not modified while HTTP was sent over TLS, the way it would be sent over TCP. Answer the questions below. How many packets did the TLS negotiation and establishment take in the Wireshark HTTPS screenshot above? If you check out all this section, you can see that 8 were needed for this negotiation and establishment. And then what is the number of the packet that contains the get login when accessing the web site over HTTPS? Okay, so the packet that requests the login is 10. If you can see here, the 10th packet requests the HTTP login page.